Crewton Ramone's House of Math. Doing short division. Alright, so what are we doing over here? We're counting how many times this one's contained in that one, right?
No. You guys know that 5 goes into 2 0 times. But how many times does 5 go into 20?
There you go.
4.
There you go. So, do you need to put that there?
No.
You don't need to. You can if you want to, and I won't say you're wrong, but you don't need to. Alright? Done. Alright, and tilt your camera down a little bit, because I'm just looking at the very tippy top of your head.
Are you serious? I have Shredder and a blanket on me.
It's okay, but just tilt it down, and then say hi to Shredder. Oh, not that far. You're now that's too far. Now I'm looking at your keyboard.
Alright, sorry, hang on.
Wait, you gotta use 2 hands.
Yeah, wait, no, I blocked you.
You blocked me. Don't do that.
Okay.
Alright. See, you gotta use 2 hands. Or you gotta, I don't know.
Shredder, come back.
Yeah. I think Shredder wow, is Shredder getting huge or what? Here, come and look. Yeah, it's fine, you can be in the thing. Wait, show him Shredder. Look at him.
Shredder's getting big.
Shredder's getting big. That's not a little lizard anymore. He's pretty good size. Have you been keeping track of his growth and stuff? Have you been measuring him?
You're frozen.
Well, you just froze too. Alright, now you're back.
No.
You have not been keeping track of his growth? I think that would be kind of a fun science project.
Yeah. Same with you.
Alright, hold on a second. Let me try. I'm going to change routers even. See if that works. Oh wow, it doesn't even see the other router. Alright, hold on a second.
Hang on, you're frozen.
Yeah, hold on. We'll get this together. The challenges of teaching math using...
I mean...
There you go, how's that?
I can see, but... Yeah.
Alright, now you're full on moving. Okay, we're good. And you're not jerky either, so good. Alright, pick another problem. Let's pick a problem.
Hang on, Benson.
What?
Okay.
And that's Crewton Ramone to you, miss. Okay, pick another problem. I'll tell you what. What if I had 20?
Or divided by...
Yeah, go ahead. How about 4 divided by 8? How many 8s? How many 8s are contained in? How many 8s are contained in 4?
2.
No, 8. That's how many 4s are contained in 8. I want to know how many 8s are contained in 0. You're correct. So I'm going to do that. This time I will put the 0. And I'm going to put a point right there. And I'm going to do that. Now how many 8s are contained in there? See, we changed the problem. We changed the problem into this. Well, yes, you do. You know. Oh, come on. How many 8s are in there?
Okay. There's 0. How many 8s are in 4?
How many 8s are in 40?
But like you. Okay, because you're like frozen on the part that you said that.
All right, sure. That's going to be your excuse. How many 8s are in 40?
Come on.
I can hear myself echoing, so I know you heard me. How many 8s are in 40?
Yeah, now I hear you. But I swear last time I didn't hear you.
Fine. Tell me how many 8s are in 40. Talk about stalling for time. How many 8s are in 40? You know this.
I know.
And you got a picture of it right here. And see, this is why. This right here is exactly why blocks. 8, 16, 24, 32, 40, and you are correct. It's 5. Because what's 4 over 8 the same as? That's the same thing as 2 over 4, which is the same as 1 over 2, which is the same as 0.5 when I convert to decimal. All of these things are going to be 0.5. Right? Let's change it. Let's change it. Let's change it. Dun, dun, dun. Oh, well, actually, I won't change this because it's going to be the same answer every time. Let's see. If I said, how many 4s are in 2? Well, none. But then I know that there's 5 in 20, right? All right. And then I can say how many, getting a vigorous nod is important. How many 2s are in 1? Well, there's no 2s in 1, but there are 5 2s in 10.
Yeah.
Is that easy?
There is.
Yes, there is. That's the correct answer. All right. Excellent. Double thumbs up. Not just 1 thumbs up, but 2 thumbs up. Okay. Let's try a different problem. Let's try one that doesn't work out so nicely and evenly. How about if I asked you, instead of how many 5s were in 20, which we figured out very easily that was just 4, what if I change this to 7? Now what? That's you. That's you. Can I count 3? Yep. 2, and so I'm going to keep track of my subtraction. That I counted 2 7s, and now I have 6 left.
2 remainder of. 2 remainder 6.
I like it. Now, what if I was being a bone and I said, "What? You can't do remainder 6 anymore. You got to be a big girl and give me a decimal." Now what? No blocks, no nothing. Now we're just going to use symbols. How many 7s? What's the closest I can get to 60?
How many 7s are in 68?
8 times 7, I like it, because 8 times 7 is 56, which leaves me with 4. Now how many 7s? See, this is going to go on for days. So do me a favor, young lady. Get yourself a pencil and paper and start figuring it out.
Can I just use a whiteboard?
You can use your whiteboard, yeah, absolutely. Especially since you just got brand new pens.
No.
I know.
I'll stay here.
Yeah, you should put Shredder in his terrarium. Shredder is not helping you learn math. Shredder is distracting you.
Look at that face.
I know, he's very cute. That's what I mean. You gotta, but he's a distraction. Look at that face. That's a face only a mother could love. He's a cool bearded dragon, but beauty is not one of their attributes. All right. So get your whiteboard out. Oh wait, Shredder, I can tell, hasn't gone back in his cage quite yet. See, we're going to do it a bite at a time. And it's good for 7s because what are we practicing here when you get right down to it? We're practicing multiplication. But we want to do multiplication so well that I don't guess. I know.
That was interrupted by that.
Dun dun dun. All right, so write this down. Get your whiteboard and pens and write the problem down on your whiteboard. Be fast. There's people watching and they're going to get bored.
Okay.
All right, so you're going in green. I like it. Go with green. Yeah. And then you got to show me so I can take some screenshots. And again, now that you don't have Shredder, you can tilt your camera up just a little bit. Dude, hold it. Yes, hold. There you go. All right, now we're happy. So far you're just copying. In a moment you're going to have to start thinking.
I know how to do long division.
All right, then all we're going to do is practice, and that makes it fun when all we have to do is practice. So keep going. It's going to be a ways. I don't think we're ever going to get to the point because, well, actually that's not true, but anyway, we'll keep going. And, all right, are we done? We're not done. We're only got, how many 7s in 40? And if I was you, I would have turned it sideways so that your whiteboard was long, because this is going to go for a ways. But I'm just going to start over here. And move over a little bit. There we go. Let's move all this stuff and that stuff. So how many 7s? What's the most 7s I can count out of 40? Can I count 6? Mm-mm. So
wait, no.
what's the most I can count? Oh, you froze. Yep, that's correct. So that'll be 35. And I'll start up here again. Put another 0. That'll be 50. Right? Now, how many 7s in 50? So close, right? I can do, how many? How many 7s? What's the most 7s I can count out of 50?
It's 7.
7. Yeah, 49. I know what you were thinking, because you were saying 49, which is correct. It's the most of, now, oh, now I'm back to 10. See, can you see how this is going to go for a little while here? Now, how many put another 0, and we're going to continue putting zeros, but I'm pressed for space and so forth, so my notation is not going to be, there's going to be teachers that blow their mind on this, but fine. Just as long as we understand what we're doing. Alright, so now what? What's the most I can do? Well, 7. Now what? Well, obviously just 1. And then what? There's 3. What's the most 7s I can count out of 30?
The most 7s you can... Wait, what?
Yeah, the most 7s I can count out of 30.
Oh, 30. I thought you said 3.
Well, it's 3, but I'm going to put the 0 there because I can't count any out of there. 4. And guess what? Now I got 28, and guess where I'm back? I'm back to this, right? So can you see I'm going to have what's called a repeating decimal? Because now look, I'm back to 2. So then I do this, and I do that. I don't know, you can't even see it anymore. Can you see that?
And then you have to write a repeat.
And then you have to put a repeat thing. How do I do that?
You do this. You put the,
There you go. Is that good? Alright, so it tells me that it's just going to be 2, 8, 5, 7, 1, 4, 2, and it's going to just keep going on. 8, 5, 7, 4, 2, over and over and over again, repeating decimal. It never ends, right? That is not a radical. That's a repeating decimal. There's a difference. A radical, these numbers don't repeat. They just, like square root of 2 or square root of 3 or pi or phi. These are radicals. Okay, that was a fun one. See, and then just with small blocks, just with small numbers, we're going to have fun. And what do we learn? We're learning on multiplication tables. We're practicing multiplication. So do me a favor. Oh, you're froze again. What the heck is going on with this connection?
Frozen.
Yeah, I know. We're both frozen. You were frozen and I was frozen. Okay, we're back now, though. All right. But the idea is, did you hear me? Is that, look, all we're doing is practicing our 7 times tables when you get right down to it, right? And you already know your 7 times tables.
7 times.
Yeah, there you go.
7 times 1 equals 7. 7 times 2 equals 14. 7 times 3 equals 21. 7 times 4 equals 28. 7 times 5 equals 35. Wait, 7
and it comes with dance moves. This is my favorite.
7 times 8 equals 56. 7 times 9 equals 63. 7 times 10 equals 72. 7 times 11 equals 77. 7 times 12 equals 84.
All the way to 12. Excellent. And the dance moves. The dance moves were the best. The dance moves were my favorite part.
The dance moves are what made them.
Yes, exactly. The dance moves are what made that one. Okay. See, that's the thing. You gotta have fun. You gotta have fun with it. Because if you're just doing worksheet after worksheet after worksheet, oh my God, the kids get bored and then they begin hating math. Alright, you know what we're gonna practice?
I forgot my phone. I need to bring it tomorrow. Okay. What?
Alright, we're gonna practice bigger. Let's practice. Alright, so you got all the way to 84. Add another 7. What do we get? So this is 7 times 12. What's 13?
I will.
What's 13?
So, hang on, I'm working it out.
We'll just add 7.
70 plus 21, what's it?
There you go.
91.
91. Very good. 70 plus 21. I like that a lot. 70 and 21, 91. All right, then what? That's easy. 14 of them is 98. Right, because I just added another 7. But now you got to do the next one. What's 7 times 15?
7 times 15 equals, hang on. 70 plus 105.
105. I like it. Let's do. We've only got 5 more to go and we're done. 16, 17, 18, 19, and of course 20. Super easy, which is just. What's 20 times 7?
20 times 7. Hang on. Wait, 20 times 7?
Yeah, 140. Done.
Okay, 1 times 7.
2 times 7 is 14 plus a 0.
40.
All right. So give me 16. 16 times 7. Now you can do 70 plus, what's 6 times 7? 42. Or you can just add 7 to 105. Either one, I don't care. Be fast.
It equals 100 and, hang on. 102, 12.
12. There's a 2 there, but that's a 12. All right. Then what? Then it's 119. That's easy. Then it's 126.
116.
Now here's the one that's interesting. 19 times 7 is 133. And guess what? Because there's a 9 in it, I add my numbers up, and 3 and 3 is 6, plus 1 is 7. Oh, look.
Hey, Ben, can I sing with 3 times tables?
You can
Or
sing.
6, whatever.
Whichever one, which you like better. Let's do 6s. Or you can do 3s, I don't care.
So, you ready?
I'm ready.
Ready.
Does it come with dance moves? Apparently it comes with dance moves. All right.
1 equals 6. 6 times 2 equals 12. 6 times 3 equals 18. And 6 times 4 equals 24.
Oh, wait.
6 5 equals 30. 6 times 6 equals 36. 6
like
times 7 equals 42. 6 times 8 equals 48.
And? Oh no!
6 times 10 equals 60.
You froze for a moment there.
6 times 12 equals 72. 6 times, oh yeah.
Alright, keep going.
6 times 13 equals, hang on.
6 times 13 equals. Don't have that part of the song memorized. Still comes with a dance move.
Hang on, 6 times 13.
Trying to see if that's in frame. Is that in frame? Yes, it is. Barely. Oh, jeez.
Hang on, you're frozen.
You're frozen
Okay.
too. You were frozen too. Alright, well, we're at 6 times 13.
78. 78.
Oh, wait. I'm gonna move over here.
7 times 14 equals 11 times 14 equals, wait, 7 times 14 equals 74. 15 times.
Now, wait a minute. Hold on, I'm trying to catch up to you. So 7, where are we at? 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. 66 is 11 of them. 72 is 12 of them. 13, 14, 15.
Hang on, you're frozen. Okay, now you're not. With Ben, some people still use their fingers to like do their times tables.
Yes, I know. In your class, you mean?
Yeah.
Those are the kinesthetic learners. Those are the ones that like their fingers and. You're a bit of a kinesthetic learner your own self. Follow.
No, but they're like
Your last.
like
Your last.
6, 7, 8, 9, 10, 11, 12.
Yeah. See, that takes
Well,
way too long. Too many steps.
14.
So here's a faster way. Here's a faster way to do it, right? If I do 6, and then I add another 6, well, 6 wants to be a 10, so it takes the 4, and now I know there's 2 left. And then I got 6, and I got 2. Well, that's not going to be happy because now the 6 wants the 2 wants a 8, and we're only going to give it 6, so we get to 18. Then the 8, it wants a 2, but we're going to give it 6, so we get to 2 10s and 4, because I take the 2 out of there, and there's 4 left. Anyway, the slow way of doing it, you're past that. I was at 102. What is, this is 5, 10, 15, 16, 17. What's 18? 18 times 6.
What?
18 times 6.
Okay, are you ready?
I am ready.
18 times 6 equals 108.
You are correct. Wow, there you go. And now look. Look over here. Can you see? Look. 666, 222, 888, 444. What do you think the next one's going to be?
Okay, it's going to be.
I know it ends in 4, and I know there's a 1 there.
114, and then it's 120.
There you go, right? Look, 30, 60, 90, 20. All right. Wait, give me a high five. Give me the virtual high five. Yep, you can keep going. Give me the virtual high five. There it is. Yeah, there it is. All the way out to 20. Right?
Okay. And then I'm just gonna probably do past 20. I don't care. Okay.
You gonna keep going? You're gonna keep going?
Where were we at?
We were at 120. Which was 20 of them.
And
26 is 120. So 21.
It's 126, and then it's 132, and then it's 138, and then it's 144.
That's an important one to know.
And then,
where are we at 144? 6 times what is 144?
And then it's 141. Oh, it's 20. 40.
Right.
And then,
Now, 19 sixes works out to 9 instead of 6. 4 and 4 plus 1. Oh wait, that's not 19. This is 19. 19, there. It's always going to be, when it's 19, it's going to be 4 plus 1 is 6 again, right? Because here is 20. That was 24. 24 times 6 is 144. And 19 times 6, the add-in will always add up to 6. That's just a little thing that you'll discover as you fool around with numbers. And you can keep going, but let's not. Let's fool around with some more division. Pick me a...
Can I do 3?
Oh, 3s are too easy. You've known 3 since you were... Okay, I'll tell you what. You can do 3s past 12. How's that? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now, then what? What comes after 10? 11 times 3 is 33. What's next? 11 times 12 is?
What? 11 times 12 is 1. Wait, 11 times 12?
Yes. Is easy.
What?
Well, no. Wait. What are we doing?
11.
We're doing 12 times 3. Sorry. 11 times 12 is just... What is 11 times 12? Oh, froze. What's 11 times 12?
121.
You are correct. All right. What is 12 times 3?
12 times 3 equals that. 12 times 3 equals
36.
36.
36. I like it. All right. Then what?
6, 12, 13 equals 39.
I like it.
And then 12 times 14 equals 141. And for 140.
Wait a minute, how do we get to 100?
Oh.
We sure didn't get to 100. We only got 3 times 14.
No, 100. What was I saying?
I don't know.
Okay. 42. And it is 105.
Wait a minute, how do we get to 100? 3 times 15 is nowhere near 100. 45.
And then it's 48.
There you go.
And then it's is 51, and then it's 54, and then it's 57, and then
It's 60.
It's 60,
I
and
like
then it's 63, and then it's 60.
Oh wow, you want to get crazy? Go ahead. 63, 66.
And then it's 66, and then it's 60.
Oh, you froze again. 69, no, I know she was going to say it. We're having issues with the internets today for whatever reason. And there's nobody else home, so I don't know what the heck's going on. Well, I mean, the boy's home, but he's not using the computer. Did you come back? Yes, you came back. All right. So look at this. This is you're all the way out to 23. 23 threes is 69. And I want you to notice that.
And then it's 72, and then it's 75.
Wait, look over here. 19 threes is how much?
Hang on.
I'm pointing at it.
77.
Where did you get 77?
I mean 87.
How did you get to 87?
84?
3 times, wait a minute, 3 times 19. 3 times 20 is 60, so it can't be more than 60.
Wait, 57.
57. Now here's the thing, it's supposed to add up to 3, but it doesn't. Oh, well, yes it does, because 5 and 7 is 12, and 1 and 2 is 3. You see that?
Hang on, you're frozen.
19 times whatever number adds up to that number,
Wait,
eventually.
Now you're not.
There you are.
Wait,
So do you see? Come on, tell me that's not cool. Because that's 19 is 57. Add those together, I get 12. And then I add those together, I get 3. If you take 19 times a number, it's that number. Every time. All right, let's fool around with something.
Hang on. Wait, I'm going to write the 3 times.
Oh, you're going to write them down? Good. I like it.
Hang on.
Using your white, turn your whiteboard the other way so you have a, because you can make the long column so you don't run out of space. And what are we doing? We're counting threes. 3, 3, 3, 3, 3. Get your threes out. You can build threes. You run out of threes, you can make them out of 2s and 1s. You know what I should do? And see, writing with a white, with a dry erase marker, it's their favorite thing. Oh my goodness. There you go. Oh, I like it. You're going with different colors too. That's cool.
Yeah.
Yeah. No, adding color makes it fun. And one more time for the adult in the room. Color is important to little girls. It is. Makes it more fun, makes it more interesting, holds their attention better when there's more color involved.
And now I need that green.
All right, go with the green. Oh, and then you gotta hold it up so I can take a picture of it. When you finish. And see, now we can throw some stuff over here like, well, let's see. How many 3s in 45? Well, I know it's 15. short division. I'm not doing the math underneath because I know my times tables. I don't have to write 30 and then subtract and then have 15 and then do and then subtract. And right? I just know that if the whole thing is 45 and one side's 3, we're talking about 15s. Here, let's draw a picture. Or not draw a picture. Let's make a math. Let's make a.
So you're ready?
Yep. Where's my?
36.
All right, hold your thing up. Hold it up. Hold it up so I can take a picture of it. There you go. Oh wait. Oh my goodness. I like it. I like it a lot. Oh she's okay. Right there. It's good. Perfect. Oh wait a minute. You changed your mouth right when I took the picture. Smile, you. Alright, that's a good picture. That's going to be a good picture. Okay, now, you know what? I want it to be 3 wide, and I want to grab these guys. I want to grab... Uh-oh. Of course, in my case, because I'm such a slob, I have blocks everywhere, except when I want them. There's a 40. It shouldn't be a problem to grab a 30, but it is. Why is it a problem to grab a 30? Oh, that's empty too. Great. I'll just throw those over there. Wow. All right. Here we go. Watch me. I'm going to throw this together in 2 seconds. Watch. Once I found my 3 block. And now my clay's trying to run away. Bam, I'm 3 across. It's as far as I can go. How far down? I'll tell you what, I'll put it right here. Can you see it? Yeah, how far down? Well, it's going to be 10 and 5 more. Oops, too many of them. Bam. How many 5s? 3 of them. Let's move. So what I do, I just drew a picture of this. I said, it's 3 across. The whole thing is 30, 45. I'm 10 and 5 more down. Done. How hard is that? Well, you're right, not hard at all. Easy? Alright, let's get bigger. What if I said I want to be 3 across?
Can I sing Dad my song?
Can you sing Dad your song? If you want to.
Okay.
Is your dad home?
Okay.
Alright.
Yeah.
Wait, you gotta throw the dance moves in. Can't just sing the song, you gotta throw the dance moves in. Yeah, in other words, you gotta give him the full show.
This is the 3 times table song. It goes up to 69. I'm gonna go backwards.
Ready? And that's the cool thing with math is you can go backwards. 69, 66, 63. Oh, there should be a video camera on this for sure. Alright. If we can get him to dance with his daughter, that would be even better. Nice! See, and what we're doing actually is division.
What did you say?
I said we're actually doing division. But in order to do division, you have to do multiplication, don't you? Alright, you. How about we get a crazy problem? You ready? Can we do 2 digits? Can we do 2 digits? Let's start off with something easy. 2 digits kind. Let's do 25. How many 25s are contained in 300? Can you do it?
25.
You're baby stepping our way up. This is 2 digits, but it should be easy. Ends in 5. Same thing as counting quarters. Same thing as saying how many quarters do I need to make $3? If I did that.
on.
Hang on. All right. Let's see. What do you think?
Let me hear you.
Can you do it in one shot?
Yeah, 25 divided by 300 equals...
Yeah.
It's dinner at 7:30.
12.
12 is the right answer. Very good. Because if I do 1,
You
I
wanna
get
know
25.
You want to know why?
Why? I do want to know why.
Okay. I'm going to sing a song about this again. Is that okay?
Yeah, sure. I don't mind.
25 times 4 equals 100, so therefore...
Oh, I like that a lot. So instead of doing it this way, you figured, well, there's 25, there's 4 of them, and that would make 100. There's algebra for you. So if there's 3 of them, then I just multiply 3 times 4 and get 12. I like that a lot. That's good thinking. Very good thinking.
Did I do good?
You did great. Nope.
What?
There's more than one way to skin a cat. Yes, absolutely, you did great. That's fabulous. All right, now let's get crazy. What if I said, I want, that was good thinking, miss. I want, let's make it 15 is contained, now we're counting by 15s. Seeing if you know your 15 times table, no problem. If you don't know your 15 times table, you're going to have a headache.
Yeah.
What should I do? Should I make it hard or should I make it, do you want a hard one or an easy one? You choose.
I would like a hard one.
Like a hard one. There you go. See, she's confident. I like it.
Yeah.
Like it a lot. All right, then I'm gonna say. Let's see here. I'm gonna call this 270 just to make it look intimidating, but it's not.
Okay.
Okay. See, if I could make it, I could have made it 300 and that would have been super easy, but that's no fun. I hope you can see what it is. See, there's multiple ways to do this. Look at this. Hey, you. How many? Just looking at it. Mr. I hate long division because I went to public school for too long. How many? You've already looked at it for too long. Alright, so does this make sense to you? What if it was 300? How many would it be?
20.
So it's... So what is it going to be?
Sorry.
Oh. Okay, 18.
There you go, done. See? Alright, that whole algorithm where you multiply, subtract, that works, but I mean, if you do some thinking, it's also pretty easy too, right? Oh, move that, whatever that is, paper towel that you just threw in front of the camera. Young lady, get rid of that. Yeah, exactly. Alright, so how many? How many? I'll tell you what, if you get this one right, we'll quit. If you don't get this one right, we'll do more.
Okay, hang on.
Okay.
I need help. Okay.
Oh, you don't need any help. You can totally do this.
This may take me a while. Just
Okay. But you see what she's doing? She's doing it the long, hard way, right? She's trying to do multiplication and subtraction instead of just doing some thinking. Yeah. So I can't count 2 of them out of there, but I can count 1 of them. And if I did that, it'd be this. Because that's 10 times 15. Those of you that teach your kids to put an arrow on here, I hope you... Anyway, I'll censor myself, but oh my god, don't do that. That's not what's happening. It's 10 times 15 is 150. And now I'm left with 1, 2, 0. Now, how many 15s in 120?
Hang on.
Since you're doing it the hard way.
Can you see what I'm doing from here?
I cannot. I can see you writing and scribbling, but I can tell that you're working, but I can't see what you're doing. Seeing if I knew my 15 times tables, or if I knew my 8 times tables out to 20, no issue. But since she doesn't quite yet, but you will by the time I'm done with you, I'd know that the 8 times 15 was 120. But she's trial and erroring a little bit over here. See, and that's what makes it hard and no fun, right? This is why your friends hate division, right there. Because they don't know what that is. How many times 15 goes into 120? How many 15s are contained? Because they haven't done their multiplication table. 45 add-ins, 400 math facts. You want to save your kids from suffering. You're not stealing their childhood. The best time to teach them this is before the age of 8. When they're in sponge mode. When they're in repeat the song over and over again until you can't stand it.
Exactement. He's telling the truth.
Exactement. Wow. Taking your French, are you? And if you get a chance to take Latin, and I know they'll give you Latin at that school, take a year of Latin.
Please, maybe. I think I'm almost there.
All right.
Oh, come on. 6, 7. Yes! It's 8!
It is 8. There you go. Love it.
Okay, do you want to see my calculation?
Yes, I do. I want to see your work a lot, actually. I want to, because I saw you scribbling so hard over there. Oh, wow. All right. So you see how much work that was? Because you didn't have 8 times 15 memorized and known, and you're, all right, there you go. All right. But no, you got it right. That's correct. All right. So we can quit early.
This is trying to follow 15 times tables.
Right. Notice how I didn't make it. Could I draw this? Yes. Do I want to? No, but I could, and I could definitely use blocks to make this happen quickly and easily.
Yeah.
Build it, but all right. Crewton Ramone's House of Math.com for more.